Hello students, today I am explaining you Unit 4 Electroanalytical Methods. Now let us discuss the classification of electroanalytical methods. That is, electroanalytical methods are classified into mainly two types. That is, interfacial methods. In the interfacial method is a phenomenon occurring at electrode solution interference. Means it's a reaction or the process which is taking place between the electrode surface and adjacent thin layer of the solution. Means where the electrode is there, and electrode, when it is coming in contact with the solution, the meeting surface, that surface undergoing a reaction, and which will be uh, discussed in the interfacial methods. That is what are measured. Mean it is a, what are the properties are measured means it is the measurement of charge, potential, current based on the species which are present at the interference on the surface which is in contact with the electrode as well as the solution. The species which are undergoing a change in charge, potential, and current uh, current are said to be interspecial methods. Now next is bulk method. In the bulk method, the phenomenon occurring, this is the phenomenon occurring in the bulk and core of the solution. That is, it measures the property of the solution. It gives the property, explain the property of the solution in the electrochemical cell. Now, electrochemical cells, that is interfacial methods, are further classified into static methods. The static method, in this method, the measurements are taken. Measurements are taken when no current, no net flow of current occurs through the cell. When there is flow of current is equal to 0, then such type of interfacial methods are called as static methods. The next is the static methods are further classified into potentiometry and potentiometric titrations. Okay, static methods are the when the current flow is 0, and such type of methods are further classified into potentiometry methods and potentiometric titrations. Now, dynamic methods. In the dynamic methods, the measures are taken when the cell is under the potential, under controlled potential or controlled current conditions. Means when controlled current is flowing through the cell, then such type of electrochemical methods are called as dynamic methods under the controlled conditions of current, or when displaced away from the static conditions. When static conditions are removed, then such type of then the next conditions which are arising are called as dynamic conditions. Okay, where the current flow is not equal to 0. In the static methods, the current flow is equal to 0, whereas in the dynamic methods, the current flow is not equal to 0. That is, the flow of current is under the controlled conditions. Okay. Now, dynamic methods are further classified into two types, that is controlled potential methods. Next is constant current method. Constant current method. Now, bulk method. Now let us discuss about the classification of the bulk method. The bulk method are classified into conductometry and conductometric titrations. Conductometry and conductometry titrations. Now, let us discuss in detail uh, the classification of dynamic methods where the current flow is not equal to zero. That is controlled potential, and the controlled potential are further classified into the five types, that is constant electrode potential, coulombmetry, voltammetry, amperometric, and electrogravimetry. In our syllabus, we are discussing potentiometry, voltammetry, and conductometry. Now, constant current method is further classified into two types, that is Coulombic titration and electrogravimetry. Okay. Now, let us discuss about the potentiometry. The potentiometry, it's like electrochemical methods of analysis which deals with measurement of electrode, which deals with measurement of electrode potential of an electrolytic solution under the constant current. Constant current means, here the constant current means zero current. Okay, potentiometry is a phenomenon where the measurement of an analysis is taking place at constant current, that is zero current. Okay. Now, the measured electrode potential, the measured electrode potential is used for the analysis, qualitative as well as the quantitative analysis. Qualitative as well as quantitative analysis. That is, quantitative analysis includes the determination of concentration of an element, which is which by measuring the changes in the electromotive force. The electromotive force is it undergoes a changes which is brought about by the addition of titrant to the sample. Means what we are doing means, here in the quantitative analysis, here in the one of the big we are supplying the titrant. Means we are as the titrant is added, the reaction is taking place, and as the reaction is taking place, the concentration get disturbed, and the change in concentration can be measured time to time uh, with the change in electromotive force, that is potential or voltage. The change in concentration which is occurring due to the addition of titrant to the sample can be measured by change in electromotive force. Okay. Now, it also includes pH measurement of pH. In this method, when the reaction is taking place between the acid and base, then it includes the measurement of change in the pH plus ion concentration, that is measurement of pH. So this method, potentiometry method, is also called as pH metry. Now, the quality by using the potentiometric methods, we can do the qualitative analysis also, that is identification of the sample, that is to detect the presence of certain ions using selective electrode. Okay. In the potentiometry, we can do qualitative and quantitative analysis, that is a change in concentration with the addition of titrant, that uh, titrant, that is quantitative analysis we are doing, as well as we are doing the qualitative analysis. Okay. Now let us discuss about electrochemical cell and principle involved in potentiometry. The principle of potentiometry is based on the fact that potential of a given sample is directly proportional to the concentration of electroactive ions. As the concentration of electroactive ions are increasing, the potential also increases. As the concentration of electroactive ions decreases, potential also decreases. Or it is directly proportional to activity of electroactive ions. Okay, that is pH. Okay, now next is electrochemical cell is a device. This is a device which can generate a electrical energy by means of chemical reaction, or by using a chemical electrical energy, it can facilitate a chemical reaction to occur. Okay, means either two processes are taking place. Either one is chemical energy is converted into electrical energy. That is chemical energy by means of chemical reaction, electrical energy is generated. And other process is by use of electrical energy, by use of current supply, the chemical reactions are taking place. Now it is used, these electrochemical cells are used to generate potential electric current from chemical reaction. These are the properties. Next is it consists of two electrodes which are in contact with the electrolytic solution. The next property is the current is generated by chemical reactions which involves releasing of electrons or accepting of electrons at the electrodes. The release of electrons is called as what? Is called as, by the release of electrons, the oxidation number of the element increases. So oxidation number increases means oxidation is taking place. And accepting of electrons, the oxidation number decreases. As the oxidation number decreases, that is reduction in the oxidation number is called as reduction. And the combination of the oxidation and reduction is called as redox reaction. So in this potential electrochemical cell, the redox reaction is taking place by means of electrical energy is generated. The electrochemical cells are of four types, that is voltaic cell, galvanic cell, electrolytic cells, concentration cells, and fuel cells. Now let us discuss about galvanic cells. The cells in which chemical energy is converted into electrical energy are called as galvanic cells. These are the devices by which chemical energy, that is a chemical reaction, is taking place. By means of chemical reaction, electricity is generated. What type of chemical reaction? A redox reaction. A redox reaction is taking place in a vessel, in a device which generates a electrical energy. That is, the cells in which chemical energy is converted into electrical energy are called as galvanic cells. In the cells, spontaneous oxidation and reduction reaction take place. The combination of oxidation and reduction reaction is called as redox reaction, and in these cells a redox reaction is taking place which generates a electricity. For example, the Daniell cell. This is the example of Daniell cell. It contains two halves. You can see here two vessels. In one vessel, zinc rod is placed in the zinc sulfate solution, and in another vessel copper rod is placed in copper sulfate solution. And the zinc rod which is placed in the zinc sulfate solution, it acts as anode with negative charge, whereas copper placed in copper sulfate solution act as cathode with positive charge. Now, a salt bridge is uh, makes a connection between the two vessels here to maintain the electrical neutrality. And the salt bridge consists of saturated agar. It is filled with agar solution, which is a jelly-like substance. These two vessels which are called as electrodes are connected by a wire through a voltmeter. Now, the zinc metal placed in the zinc sulfate solution undergoes oxidation reaction, loses 2 electrons and converts into Zn2 plus. That is, zinc is undergoing a oxidation. The oxidation number of the zinc is increased by the loss of 2 electrons. You can see here. Zinc is losing 2 electrons and undergoing a oxidation. That is, zinc increasing its oxidation number from 0 oxidation number to +2 oxidation number. In the metallic state, every metal is existing a 0 oxidation number. It is losing 2 electrons and getting a +2 oxidation state. From 0 to +2 oxidation state is increase in oxidation number is called as oxidation. Now, these 2 electrons moves from zinc rod to copper rod through through this wire, through the voltmeter. And here the copper sulfate solutions accepts the 2 electrons, the copper sulfate solution in that copper 2 plus accepts the 2 electrons and undergoes reduction. From copper +2 to it goes to the metallic copper, that is +2 to 0 oxidation state. It is reduction. Here +2, copper +2 accepting 2 electrons and to form metallic copper, that is a reduction reaction. Now, cell reactions. Anode reaction. At anode, what type of reaction is taking place? Oxidation. That is, zinc is losing 2 electrons to form Zn2 plus. At cathode now, copper 2 plus accepting to the 2 electrons which are transferred from zinc to copper rod through a wire, and copper +2 ions present in the solution accepts 2 electrons to form metallic copper, which is a reduction reaction. Now the net reaction, cell reaction, is copper plus zinc plus copper 2 plus gives rise to Zn2 plus copper. This is the net cell reaction. This reaction is called as redox reaction, which is a combination of oxidation and reduction reaction. By the use of this redox reaction, the cell energy is developed with the galvanic cell. Now, let us discuss about indicator electrode. The indicator electrode is an electrode which is used to measure the unknown potential or pH of the given solution. In the given solution, to know the potential of the given solution or pH of the solution, this indicator electrode is used. By taking help of reference electrode whose potential is known, it gives a measure of potential or pH of the solution, which is when into which it is dipped in comparison to a reference electrode having known potential. Okay. Now next, indicator electrode responds to change in EMF or pH of the solution. Whenever the chemical redox reaction is taking place, whenever the redox reaction is taking place in the solution, the change in pH is taking place or EMF of the potential is changed, which can be identified or detected by indicator electrode taking reference electrode potential as reference. Okay. There are four types of indicator electrodes. They are hydrogen electrode, quinhydrone electrode, antimony oxide electrode, gas electrode. Now, let us talk about reference electrode. Reference electrode is an electrode which has stable and lived potential. That is, the potential of reference electrode does not change on dipping into any solution. When it is dipped into any solution, its potential does not change. So it is having a known potential. By taking the taking the potential of a reference electrode as reference to the indicator electrode, the potential in the indicator electrode can be measured by taking help of reference electrode. Now, it gives an standard and known potential. It is used as one of in the electrochemical cell. In the electrochemical cell, this is the electrochemical cell in which one part is indicator electrode with unknown potential and another part is reference electrode with known potential. That is, here it is used as one of the electrochemical cell for determining the potential of the given sample. It is used in combination with indicator electrode to measure the potential or pH of the solution. This reference electrode is used to measure the potential and pH of the solution. Now, the construction part, the outer part of the reference electrode is filled with saturated KCl. The outer part is filled with saturated KCl, potassium chloride, and the inner part of the reference electrode is filled with mercurous chloride or AgCl or thallium amalgam, thallium chloride paste. And the device, and it is made up of glass broad sleeve ceramic plug and fitted disc to form a liquid junction with the solution into which it is immersed. That is, here it is maintaining a liquid junction where the two solution are coming in contact. Okay. Now, the reference electrode should fulfill three important requirements, that are stability. It should be stable over a long period of time. The potential should be stable over the long period of time. Reversibility. It should be in equilibrium with its ions, should not show any deviation in its potential when small current is applied. When you are applying a external current, there should not be any deviation. There should not be any deviation in the ions. The whatever the chemical reaction should be reversible with the application of current. And reproducibility, it should obey Nernst equation and should measure the potential within the accepted standard deviation range. Okay. Normal hydrogen electrode. Normal hydrogen electrode, it is also called as standard hydrogen electrode. It is a primary standard electrode for measuring the pH or potential of the solution. It acts as both indicator electrode as well as the reference electrode. It consists of platinum wire. It consists of platinum foil here, which is coated with platinum black. This coating increases the surface area of the electrode. This coating increases the surface area of the electrode, which helps in establishment of electrode reaction, which helps in to conduct the chemical reaction, that is redox reaction taking place at the electrode. The platinum foil, this platinum foil is connected with a platinum wire. Platinum wire is enclosed in this whole system. The platinum foil and the platinum wire is enclosed in a glass tube and with a inlet from where hydrogen gas is supplied at a pressure of 1 atm. At a pressure of 1 atm, and hydrogen gas is pure to a 99.8%. This platinum foil is dipped in a, if it is dipped in a standard solution, it act as when this electrode is dipped in a standard acid solution, it act as reference electrode. Whereas when it is dipped in a unknown solution in which concentration is unknown, then it is used to identify the H plus ion concentration and potential or potential developed in the electrode. So it acts as indicator electrode. Here, electrode and the solution should be completely saturated with hydrogen gas. It should be completely saturated with hydrogen gas. And the electrode reaction is given as H plus. On receiving one electron, it gives 1/2 mole of hydrogen gas. On applying of Nernst equation, the potential of the solution H plus ion concentration is equal to standard potential minus 0.0591 divided by 1 as n value equal to 1 year, and log 1 by H plus ion concentration, product by reactants, 1 by H plus ion concentration. Here, since the standard potential, that is standard potential of the hydrogen electrode at standard conditions, that is at standard conditions, at standard temperature and pressure is equal to 0. That is standard potential is equal to 0. So on substituting here 0, we are getting H plus, the potential is equal to, cell potential is equal to 0 minus 0.91 by 1. H log 1 by H plus ion concentration. Here minus negative logarithm of H plus ion concentration is nothing but pH of the solution. So here the potential is equal to 0.591 pH. Then pH will become equal to potential of the cell divided by 0.591. Normal hydrogen electrode. Let us discuss the advantages of normal hydrogen electrode. The first advantage is it is used as reference electrode as well as indicator electrode. It is used as fundamental reference electrode against which the potential of other electrodes are measured. It is act as fundamental reference electrode. Okay. It gives accurate results. Its internal resistance is low, and it does not show any salt error. It is suitable for measuring pH over an entire pH range. Now let us discuss about the disadvantages of normal hydrogen electrode. First is the presence of strong oxidizing or reducing agents affects the functioning of this electrode. The platinum foil has to be platinized regularly, and compounds like sulfides, cyanides, arsenic, alkanoids, etc. poison the platinum surface and affects the potential of the electrode. Even pressure of hydrogen gas and its purity affects the electrode potential. Now, QUINHYDRONE electrode. Now let us discuss about QUINHYDRONE electrode. This is indicator electrode. This is an indicator electrode which was introduced by Gilman in the year 1921. This electrode is introduced by Gilman in the year 1921 for measuring the pH of the solutions. It consists of platinum wire dipped in the solution saturated with quinhydrone, and quinhydrone is a chemical compound which undergoes a reversible decomposition in the solution to give equimolar quantities of quinone and hydroquinone. The platinum wire, you can see here, platinum wire dipped in the solution, saturated solution, and this electrode consists of quinhydrone, a chemical compound which undergoes reversible decomposition to give equimolar quantities of quinone and hydroquinone. Here you can see here, this is the quinhydrone. This molecule is called as quinhydrone, which on decomposition gives hydroquinone and quinone. This is the reversible reaction. Okay. Quinone and hydroquinone give a reversible redox reaction. Now here, quinone on, which is in the equilibrium with quinone, which is in equilibrium with hydroquinone. Now the potential of this electrode is given by E. Potential of the indicator electrode is equal to 0.699 minus 0.05991 pH. The standard CALOMEL electrode is used as reference electrode for this QUINHYDRONE electrode. E naught is equal to, that is standard potential is equal to 0.2422 at 25 degrees centigrade. Hence, EMF of the electrochemical cell is determined by this equation, that is electromotive force of its cell is equal to the electromotive force of the indicator electrode minus electromotive force of the reference electrode. Now let us discuss the advantages of QUINHYDRONE electrode. The internal resistance offered by this electrode is very low. The simple and easy to operate gives accurate results. The equilibrium of the electrode with the sample solution is attained within 1 to 5 minutes. And the next is used for non-aqueous solvents. It is used for non-aqueous. Now, let us discuss the disadvantages of QUINHYDRONE electrode. The first disadvantage is it cannot be used above the pH 8, as hydroquinone undergoes oxidation in the alkaline medium. The next is it contaminates the test solution by altering the equilibrium between quinone and hydroquinone. Whenever the equilibrium is disturbed between the quinone and hydroquinone, it contaminates the solution to be analyzed. Its use is restricted in the presence of oxidizing and reducing agents. It gives salt error. It is unstable above 30 degrees centigrade. Now, let us discuss about standard CALOMEL electrode. It consists of outer tube containing a saturated KCl, and an internal tube containing a paste of mercury and mercurous chloride, which is also called as CALOMEL. And because of this CALOMEL, this electrode is called as standard CALOMEL electrode. The saturated KCl serves as a connective bridge. That is just like a salt bridge. It is serving as a connective bridge between the CALOMEL and a sample solution into which the electrode is immersed. Okay. The contents of inner tube are in contact with the outer tube through a small orifice. Here the small opening will be there. Through this, the contents of inner tube will be connected to the outer tube through a small opening, that is a small hole, that is called as through a small orifice. Now, to maintain the electrical connection between the contents of the electrode, the sample solution electrode and the sample solution, a small and constant flow of electrolyte, that is KCl, is maintained. This continuous flow of saturated KCl is maintained to maintain the electrical connection between the sample solution and a sample solution and the electrode. Between the electrode and sample solution there should be a connection. To maintain this connection, the constant flow of saturated KCl is maintained. Now, a CALOMEL, if the lithium chloride is used as a salt bridge, that is connective bridge, instead of potassium chloride, it is used for measuring non-aqueous solutions. Non-aqueous solution, instead of using the potassium chloride, we are using the lithium chloride as a connective bridge, that is salt bridge. Now, advantages of CALOMEL electrode. Standard CALOMEL electrode can be used in various solvents. It can be used over a wide range of pH range. Now the next is disadvantages. Its temperature coefficient is low, hence cannot be used at higher temperatures. It cannot be used in the solutions which shows Cl minus interference. Now let us discuss the applications of potentiometry. The first application is determination of equilibrium constants. The equilibrium constants of the reversible reactions can be calculated by using of potentiometry, and it is also used to calculate ionic product of water. Now the next, it is used in calculating the dissociation constant of acids. Next, it is used to study solubility and solubility products of sparingly soluble electrolytes, that is sparingly soluble salts. To know the solubility of sparingly soluble salts or solubility product of the sparingly soluble electrolytes, this potentiometry is used. To determine the activity coefficients, the potentiometry is used. To study the composition of complex compounds and instability constants of complex ions in the complexometry, the potentiometry is used. To know about the valency of metal ions, the potentiometry is also used in the to find out the valency of metal ions. Now, the potentiometric methods are used in determination of nitrogen trioxide, nitrogen trioxide and nitrogen dioxide in meat preservatives, and it is also, these potentiometric methods are used to identify the content of sodium chloride in meat, fish, dairy products, and fruits, juices, etc. The potentiometric methods are used in the estimation of potassium, calcium, iodide, chloride, cyanide, nitrate, and ammonium in the soil, fertilizers, feedstuffs, and plant materials also. The potentiometric methods are used in pollution monitoring, that is estimation of cyanide, fluoride, sulfur, chlorine, nitrate in the industrial water, to estimate the content of These are the species in the industrial water. The potentiometric methods are used, and even to know the content of, to find out the content of fluorine present in the drinking water, the potentiometry method is used. In biochemistry also the potentiometry method is widely used, that is to in order to analyze the calcium potassium chloride in the body's fluids like blood, plasma, sweat, serum. The potentiometric methods are used, and it's one of the application is in the detergent manufacture to study the effects of calcium, barium, and fluorine on water quality. These potentiometric methods are used in pharmaceutical industry to determine the pH of the given chemical agent, and also in the detection of endpoint in the potentiometric titration of certain drugs like amyloxin, etc. These potentiometric methods are widely used.